I'm Meg.
I'm Michelle.
I'm Gemma.
And I'm Blake.
And together we designed
a digital technologies lesson sequence
for Year 2 called Caterpillar Coding.
Throughout the lesson sequence, we have considered a variety of features, including the Australian curriculum, Australian teaching standards, and the diverse learning needs of students. We have designed the lesson sequence based on the TPACK framework, where technological, pedagogical, and content knowledge have been fused together. Fusing technology into our pedagogy is revolutionising how we teach content, providing new ways to access, process, and display knowledge. This framework has been used to create a meaningful and effective learning sequence, providing rich opportunities for problem solving, design, collaboration, independent learning, and critical and creative thinking.
The lesson sequence has been designed with the intention of enhancing students' knowledge of coding and computational thinking. So first of all, computational thinking, by definition, is the process we draw on when solving complex problems and creating systems that a human or machine can effectively carry out. The Australian curriculum describes this as a problem-solving method that involves various techniques and strategies that can be implemented by digital systems. However, coding is the following of algorithms to reach a solution, using strategies such as decomposition, abstraction, and patterns.
Why should we code? When children learn to code, it helps them to develop essential skills such as problem solving, logic, and critical thinking. Students are encouraged to become creators, not just consumers of technology they use. Through coding, children can learn that there's more than one way to solve a problem. Simple and efficient solutions are often better.
Coding and computational thinking have been derived directly from the Digital Technologies curriculum for Foundation to Year 2. From the Digital Technologies Knowledge and Understanding strand, students recognise and explore digital systems, hardware and software components for a purpose. From the Digital Technologies Process and Production Skills strand, students follow, describe and represent a sequence of steps and decisions needed to solve simple problems, and create and organise ideas and information using information systems independently and with others, and share these with known people in safe online environments.
The lesson sequence has been designed to contextualise learning through the other areas of the curriculum in order to provide an engaging learning experience. The students are meeting the content descriptors for Year 2 science curriculum. Students have read the book The Very Hungry Caterpillar, and in science are investigating how living things grow and reproduce. Here, our theme arises for students to create a Scratch Junior movie to demonstrate the life cycle of a butterfly.
Within the designed activity plan, computational thinking and coding will be thoroughly investigated through the program Scratch Junior. Students develop coding skills and concepts within this visual medium through a structured sequence of activities that will result in a multimodal presentation of the life cycle of a butterfly. Through explicit teaching of algorithms, debugging, sequencing, and programming, with these new skills, students will present a product depicting the life cycle of a butterfly.
In the first lesson, students are introduced to the idea of computational thinking. Students are given a context to build their computational knowledge by watching an animated video of The Very Hungry Caterpillar. They are then provided with an opportunity to investigate into the Scratch Junior software independently, as well as led through a scaffolded explicit teaching instruction, unpacking the functions of repeat and repeat forever.
Building from the first lesson, students move into the higher order thinking computational skills of sequencing and algorithms. To build understanding of sequencing, students engage in a real-world activity, highlighting the importance of illicit instruction when writing code. From this, students will move into Scratch Junior and start producing their own algorithms with a key focus on directional language and outputs. These consist of move up, move down, move left, move right, turn clockwise, and turn counterclockwise.
Within the third lesson, students will be building their computational knowledge by further extending their understandings of algorithms. Throughout this lesson, students will be investigating the additional functions such as grow, shrink, set speed, pausing, and adding speech bubbles. From this, the students will produce a complex algorithm with the intention of moving a caterpillar through the second stage of the life cycle.
The fourth lesson allows for students to present their computational understanding and skills through the production of a short multimodal presentation. In pairs, students will create the life cycle of a butterfly, demonstrating their new understandings of the digital system Scratch Junior. Each student will use their computational knowledge of sequencing, algorithms, and debugging to create a final assessment piece. Once completed, the students will present their short multimodal presentation to the class and upload it to a safe online school sharing application, allowing for parents and teachers to view.
Thanks for watching!